Hello guys, DataPandas here. If you don't know me yet, I'm a software engineer and a data scientist, and DataPandas is an ongoing project that will help you to create your own coding knowledge. Today we are going to see the famous algorithm about the two-number sum and three-number sum. The task is very easy to understand. So the task is finding a function that takes in input an array of distinct integer. Is important that they must be distinct, and a target. So this function taking input an array of distinct integer and a target, and as output returns all the couples inside the array whose sum is the target. So if we sum all the numbers inside a couple found, we will get the target sum. So let's say, for example, let me jump into this problem. Let's say, for example, the function is taking input an array and a target, as we say, and as a result, as output, we get the response. So let's say, for example, the array is 1, 2, 3, 5, and the target is 8. The only good couple, the only two numbers whose sum is the target are 3 and 5. Let's say, for example, here, the only two numbers in this array, if I sum two of these numbers in this array, I can get 4 only with two numbers, only with one couple that was 1 and 3. So 1 and 3 are my two numbers that allow me to get this target 4. Say, for example, here we have 0. We are going to do the same things with two-number sum and the three-number sum. The three-number is very, very similar to the two-number, but instead of have a couple, we have a triples. So here, the only triples that allow me to get this target 8 are 1, 2, 5. So I don't mind, for example, if 3 and 5, this couple make me 8. In the three-number sum is the same problem like the two-number sum, but with triples. So I need at least three numbers. I need at least three numbers. Okay, let's jump into the problem. So right now we are looking for understanding how the two-number sum is working, how the two-number sum algorithm is working. So repeat again, finding a function that takes in input an array of distinct integers and a target, and as output, as a response, returns all couples inside the array whose sum is the target. So if we go inside this example, again, we have this kind of array, this target, so the array and the target. We have to find the function, the Python function. We have to build, we have to write the function that allow us to get this kind of response. So let's jump very quickly into the solution. I show you the slide. And right now we try to thinking how to implement this algorithm. So let's say, for example, that we can just thinking about an array, and let's say, for example, we have an array like this: 1, 2, 3, 4, -1, -2, 5. So this is our array. This is the array that we have. And we have to work with this kind of target. Let's say, for example, we can put the target here. This is our target. The target, let's say, is 4. Okay. How we want to reasoning, how we want to thinking. we want to think about this problem. So what we can do is we have to find a solution that is, for example, the first solution that I can think is if I do a cycle, for example, a for inside a for, it could be very easy to implement because I can find all the couples that has as sum the target for. But this one is pretty much complex because I have to do a for inside a for, so my complexity will be at least in the raw scenario, of course, at least in the raw scenarios will be big O of n square. And if n is, I don't know, if it's 10, even if it's 100, it could be fine. But if n is 1 million, we could have some problem because the complexity is n square. So it's very, very high. Right now we're just thinking about another solution. And another solution could be, let me just removing this kind of comments. Another solution could be this one. So first of all, let's thinking about this other solution. We need to sort our array. We need to sort like this. So for example, -2, in this case, 1, 2, 3, 4, 5, very easy. And then what we can do is not using for again, but using, we can, of course, we have to use a kind of for, a while, for example, a while loop, to study the dataset from 2 points. The left point and the right point. And just moving this point from left to right and from right to left, we can navigate inside our array and find the best solution. But let's jump into an example. So let's say, for example, we start with the first one, extreme value, the first one and the last one. So let's see. I take this couple, -2 and 5. So of course the sum will be -2 plus 5 is 3. At this scenario we have 2 choices. First of all, 3 is less than 4. 3 is equal to 4. Otherwise 3 is greater than 4. So this algorithm wants that at this point, what we can do is, so in this scenario, it means that my total, we can call this one my total. My total is less than the target. So I have to increase my total to achieve the target. How can I do that? The only way is I cannot move my right pointer, because if I move my right pointer to left, I decrease my total. I have of course to move my left to right in order to increase my total. So in this scenario, what I can do is moving my left pointer to right. What I can do in this scenario, easy, it's the opposite, exactly the opposite. The right, I have to move my right pointer to the left. What I have to do in this scenario? In this scenario, okay, finally I found a good couple. So for example, in this scenario, my first couple, very good couple, is -2 and 5. And I have to move the left to the right and right to the left to find other solution. So let's jump into this reasoning. Say for example, in this scenario, of course, we are in this specific case, 3 less than 4. And what we can do is moving the left pointer to right. So we're just doing -1 and nothing changed to the right pointer, is 5. And now I have -1 plus 5 that is equal to 4. That's great. I finally found the first solution, that of course is not this one. Let me remove it. But my first true solution is the couple -1, 5. What I have to do next? Okay, I found the solution, so I'm right now in this scenario. I have to move the left to the right and right to the left. So what I can do is move again, jump again to here, and jump this one here. So I have 1, sorry, let me remove here, 1, 4. That the sum we know is 5. And okay, we have a problem. I have to move again my right pointer to left. So 1, 3. The sum of course is 4, and it's perfect. I found a new couple. So right here I have 1 and 3 is the other couple that is good for my solution, for my target. And then if both are good, I have to move my left pointer to right and my right pointer to left. So what I have to do is moving here in 2. And right now my algorithm says stop, because I don't have enough value. Someone can say, okay, but 2 plus 2 is 4. Okay, but this is not the case, because like we said in our slide, the array of distinct integers and can take only one time. So that one is perfect, and we stop our algorithm. Let's jump right now into the code and see how to write in Python this code. So let's jump into the code. What I can do is save my array. You can just copy the one that we use, for example. It's 4, -1, -2, 5, perfect. That's it. My target will be 4. And of course, we try to implement the easy solution, the easy to understand solution, that is 4 inside 4. And we can just do in a very easy way, because we need just the length of the value, that is that, like we say, it's the length of the array. So we can just loop this array in a very easy way. You can just do the length, and then what we can do is so we have to do a 4 inside another 4. So we have to do again 2 times. We have to cycle all the sorry, I write wrong here. all the data set, all the array, sorry, and my total could be, like I say here, my total, of course my total is equal to array E plus array J in J position, and easy, if my total is equal to my target. Another condition that we can put that E must be different from J, so we can avoid this 2 plus 2 that it's not true because it's the same element. And then we can do just response DataPand. We can save a response here that is an array, of course. So response append, and we can just append just this one, like an array, of course. Just putting here, and so what I'm missing here is probably an equal, probably that's it. We can just print this solution response. Let's see what's happened here. Okay, here we have all the possible combination, and of course are duplicated because this is the EJ solution, and this is one is the J I solution, because I cycle my dataset twice. What I can do in a very easy way could be, so this one is the time complexity is of course is here the time complexity is n per n, so is n square. What we can do to remove this duplicating is could be very easy. Say for example here we don't take all our dataset, but we take only a portion of our dataset. So let's say for example here I want to take the dataset, just say for example like this. I have okay, suppose that this is all my dataset. So every time I'm here, this is my E, I can take, it's not important to return to the previous value, for example here, it's not important. The most important part is go forward and take all this value in yellow. When I cycle, this is the J domain. Of course E must be all the black one line, all this black one. But the J could be only the yellow one, only one portion. So what I can do to remove my duplicate could be, so not take all this range, all the array, but very easy way, take only the E, and remember the syntax probably is inside here, is of course +1 because I don't want the same, so I can just remove this one. Because I'm saying take J that is E plus 1, at least E plus 1. So I can remove this condition as well. And then I can run this command. I can run this command and find all my unique solution. This is a way. Otherwise I can clean my, if I go, sorry, let me copy this one. If I go in my previous solution, is this one. I can remove this value if I want. This is another option. But like I say, this is n squared time complexity. And the space complexity could be 0, could be 9, because if I save the response in a specific array, it could be 9. If I return directly, could be 0. But stay focused on the time complexity right now. Because right now I want to show you the while solution. So with the left and right pointer and moving this left and right pointer. Stay careful because the left and right pointer are very important in a lot of algorithm, a lot of study about the algorithm. So let's say for example, I have the same array here, the same target here, and response length, I can use all of that stuff. So right now I do a while that is true until left. So the left pointer is less than the right pointer. Otherwise, I stop, completely stop my loop. So what I can do is just using the same code that I use. So I have my total that is equal to array left plus array right, and in this scenario I did not define left and right. So the left for the first cycle is 0, and then for the other one is my length minus 1. And then what I can do here is, of course, the same scenario. I can just copy here. So if is less, and then what's happen if is greater than, and what's happening if is equal. Let me just formatting better this one. So in this case, in this scenario, what we have to do is moving, like we say, moving the left to the right. So the left pointer, you have to move to the right, just like this. Left, move to the right. In this scenario, like we see during the explanation, very easy, we move the right to the left. So we have the right to the left, not plus but minus. And in the last scenario, what we can do, just removing this one, just moving both, but for sure before we have to append our index, our value, the good value that we found. That's perfect. Let's just run this kind of solution. And right now my response is empty. Sorry, is empty. Why? Why is empty? Maybe I'm missing something. What I'm missing? So I'm just moving the right to the right. The left probably is wrong. The left. Oh, a very important things. That's why. Don't forget. Never forget this important step. So I can show you better right here. Sort. It's very important to sort this algorithm, because if we don't sort, all the concept behind moving the left to the right and the right to the left to increase or decrease our value make no sense. So very important, very important is, of course, sort our array before do everything. So let's just run this code, and now it should be fine. We found the solution. So that's pretty much for the two number sum. Very easy to implement. And the concept behind the left and right pointer is very important to understand. Okay, now let's jump into the second topic, that is, like we see, the three number sum. It's a little bit difficult, a little bit tough, but not so extremely. It's not crazy solution. I'll show you very quickly. So if I go in my very easy here, okay, I'm trying to explain right now how it's working here. So let's take the previous dataset. So we have, let's do with the black one. Okay, 1, 2, 3, 4, -1, -2, 5. Of course, here as well, we can do a 4, or 4, or 4. But it's very, very complex doing this. Like before, this scenario is very, very quick because it's n. The powerful of this algorithm is that run in n. It's n complexity. The time complexity is n. And here, the time complexity right now, if we do with 2, 4, is n, n, n. So n 3. It's very, very high value. We want to reduce it. So we can just use the concept behind the 2-number value, and we can use with 3-number value. But right now, what we can do is cycling each element in this array, and moving this element. And so just let me remove it. We can just stop the value, stop the first value, for example this one, stop the first one, and investigate it on the left pointer and the right pointer on the subs dataset without the first element. This one is an L like left. So what we can do is stop the first one element. Of course, first of all, we don't forget we have to sort our dataset. We have to sort. This is very important step because without this condition, all fall down. So right now we stop the -2 and we work with the left and the right. So -2 is the first one, then try with 2 and 5. So I sum this value, -2 plus 2, 5. The target is always 4. So let me write the target. Target is 4 as well. So this one is 5. So what I can do? 3 choice. First of all, if it's -4, if it's greater, so what we can do here? Probably equal. Okay, equal. If it's minus, if it's equal to 4, if it's greater than 4. In this case, we move the left to the right. In this case, we move it to the right to, sorry, I made a mistake. It's on the contrary, exactly the contrary. We move the left to the right. In this case, we move the right to the left. In this case, we move the right to the left. We move the left to the right, and we save solution. Because we find, it means that we have found our solution. So it's 5. We are in this scenario. So just let me move the right. So -2, 2, stay like before. I don't move the left pointer, I move only the right pointer. And just let me move here 4. So let's see, -2 plus 2 plus 4. This one is 0. The result is 4. Great, I found a solution. Finally, I found a solution. I save my solution. That is -2, 2, 4. And jump again, save my solution and move this pointer. So I can move -2. Right now I have -1 and 3. So let's jump here, -2, -1, 3. The sum is 0. Okay, -2 minus 0 is is of course less than 4, so let me move the left. So I have 1 and 3. So again, minus 2, 1, 3, and the sum is 2, and so on and so forth. This is the concept behind, and when I cycling it again, okay, perfect, what I can do is remove this value, start from this one, and use again a left pointer that is the I element plus 1. This one is the left. And I take again the right. That is the last one. So let me just put into the code. Oh, sorry, just here. Okay. So this one is the third number sum. How we can solve it? Okay, let me just copy the array. Very easy. First of all, of course, we can do 4 in 4 in 4, but it's very complex. Instead, the solution, it will be not n with 3 on top, but n square. This kind of solution. The time complexity will be O then n square. So first of all, we have to do E in range again of the left. And here what we can do is define the left like the I plus 1, because we say that must be the other pointer must be the I plus 1, and the right pointer is the last one. So the right pointer here is the last one. So the left minus 1. Of course, we take minus 1 because if this one is a 7, the position starts from 0, and this one is the 6. I think for the one that are very new in programming language, it could be useful. So how we solve it? So while we do the left until left is less than right, okay, what we can do is so my total sum, defining my total sum would be very similar to this one, but plus, of course, the I element. So I have these 3 solutions again inside my code. Let me just fixing here, fixing here, fixing here, perfect. So if my total, again, it's very similar. Here, just a difference. So if my total is less than my target, I have to move my left pointer. If my total is greater than my target, I have to move my right pointer. Otherwise, I can append my new value. And this is pretty much the solution. Let me just run this solution. Let me just see the response. We have only one response, 2, 4, minus 2. Let me check it's fine, probably, because I can see that 5, 1, 5 minus 1. Probably there is another solution. Let me check if I'm missing something. This is my solution, 1, 2, 4, 1. Probably this is the last, is the only one. Let me check if my writing right, if I can see other solution with my eyes. So 5 minus 1, I got 4. So probably is 3. So probably there is also 2, 3 minus 1. That is 4. Why I cannot see here? Probably I'm missing something right now. What we can do, because I can see clearly that minus 1, 2, and 3 is my solution, because minus 1 plus 2 is 1, plus 3 is 4. Again, guys, again. Never forget to sort my loop, my array. If I run again, must be sorted. I find all the solution. And that's it. That's the real solution of my problem. I jump into this little error, but just to focus you to sort the array before. It's very important to sort. And don't forget to double check with your eyes possible solution with small dataset, with small array. And then once you are sure that your function is working well, you can work with big array as well. I can save. So what else from DataPandas? I think this is pretty much all the job. Don't forget that this kind of solution is a big O of n square. Even if we have to sort, because it could be, sorry, oh, it's small. Just a second, let me open this one. Okay, because even if is n square plus log n, if n is very big, this one is removed. And the same for the previous one. It depends, but usually log n, in particular if n is very big, this one is not could be not important. Of course we have to consider that in this case we are order, and so we have a component of log n, but in this scenario, for example, is very it's very small. It's very small because in this scenario the n square is so much bigger than log n. It's growing in very fast way, so this doesn't mind. In this scenario we have n, and with n we have to consider also this log n proportion. But of course it's better than have n square. N square, we have n square in the two number sum if we do a 4 inside a 4. And we have n with 3 at top if we do 4 inside a 4 inside a 4. So stay careful on that. This is pretty much all from my side. Don't forget to follow me on Instagram, TikTok, and YouTube. Thank you for watching. Thank you for your time. See you in the next video.